Alright, in this video we will solve this tiny inequality and we will put our answer in interval notation. So the first step is to imagine this problem as an equation instead of an inequality. Solving this will give us the boundary points that we need to use. So this is factorable. This is the difference of two squares. So I will solve this by factoring. X to the fourth power minus 1 will factor as x squared plus 1 and x squared minus 1. Now, x squared minus 1 itself is the difference of two squares again. So I can factor this more by writing x plus 1, x minus 1. Meanwhile, I will just bring down the x squared plus 1, which is not factorable. So I have these three factors. If I set each of these equal to 0 and solve, it will give me the zeros of the function, which will in turn give me the border points that I need for the graph. So if I set x squared plus 1 equal to 0, and x plus 1 equal to 0, and x minus 1 equal to 0. Well, in this case, subtracting 1 from both sides gives us x squared equals negative 1. If you take the square root of both sides, that's going to be plus or minus the square root of negative 1. If you have a negative underneath a radical, that's going to be I. So we have plus or minus I. So imaginary zeros are not going to show up on a number line. So these are really pointless, literally. So if we look at these other two, x plus 1 equals 0, subtracting 1 from both sides, we get x equals negative 1. So that's one of our border points. And adding 1 to both sides here gives us x equals 1. That's a border point. So let's take these two values and put them on a number line. Okay, so here I have negative 1 and positive 1. Now let's do some test cases in one in each zone. I've got these three zones. So to the left of negative 1, I'm going to try negative 2 and see what's the value of the function there. Between negative 1 and positive 1, I'm going to try 0. And to the right of 1, I'm going to do positive 2. At the border, because it's greater than or equal to 0 that I'm looking for, I need to include the border points which will equal 0. So I will include them by writing closed circles at the border points. If this had just been greater than 0, I would have used open circles. Okay, I'm going to use my TI-30XS multiview to help me out. Alright, let's go to the table feature and type in x to the fourth power minus 1. So x to the fourth power minus 1. Alright, I'm going to use the ask mode instead of the auto mode for this activity. Alright, now my three test values are negative 2, 0, and positive 2. So I'm just going to type those in. Negative 2, 0, and positive 2. So I get 15, negative 1, and 15, the value of the function at those points. Okay, so I got 15, negative 1, and 15. Now, so the question is the function greater than or equal to 0? So is 15 greater than or equal to 0? Well, yes it is. What about negative 1? Is that greater than or equal to 0? No, negative numbers are all less than 0. What about, well, 15 again, we already spoke of that. So we already know, yes, that is greater than 0. So these yeses tell us where the solutions are. So everything to the left of -1 is going to be a solution, and everything to the right of +1 will be a solution. But we need to write our final answer in interval notation. All right, so we actually will need two separate intervals, one for each one of these arrows. So over here, this is coming in from -infinity to -1. So there I've got -infinity to -1, and I'll use a square bracket. And this arrow goes from 1 to infinity. All right, it's a closed circle, so I do a square bracket, 1 to infinity. Whenever you have more than one interval as part of your solution, you're going to use this union symbol to join them. Now, they're using these braces. You know, this was question was generated by software, and they're using braces instead of square brackets. So everywhere you see a brace, let's just go ahead and make that into a square bracket before we look for our answer. So these are square brackets here, square bracket. Okay, now, where is the answer? So -infinity to 1, union 1 to infinity with the square brackets. So the answer is B.